Okay, good morning or good afternoon. I don't know when this video will be presented. Welcome and thanks for being interested in this talk. My talk today is about a convolutional neural network-based computer vision interface for prosthetics control. And my name is Emanuele, and I work at the Robotics Lab, School of Mathematics, Computer Science Engineering, Liverpool, Open University, UK. This work was developed with my colleagues, Mr. Daniel McHugh and Dr. Neil Buckley, and I take this opportunity also to thanks all my colleagues for this, in particular also Daniel for his work and Dr. Buckley for his work as well. So thank you. So let's start. So this is the outline of my presentation. I'm gonna give you a brief introduction. Then I will look at materials and methods in terms of hardware, so what we have done. And then I will do, some brief overview on the materials and methods in terms of software. We spend a few minutes also on the libraries, just to give an idea of how we organize this work. And then I will present some preliminary results and talk about some conclusion discussion. So what's the problem? The problem is that you know that we're talking about robotic / prosthetics. And one way to try to improve what we have in terms of prosthetics and robotics is to try to introduce some AI on these systems. And the reason why we want to improve this system is because, statistically speaking, there is a lot of people who may benefit of that. There are 2.1 million people in the US that live with a prosthetic limb. There's people that, unfortunately, they have some traumatic events where they got an amputation and so on. So we look at, in particular, we focus on upper limb prosthetics / robotics, and in particular we look at robotic hands. But what we're going to show can be also considered extended to other systems, not necessarily upper limb, not necessarily hands. We're going to show you a proof of concept that AI and prosthetics can be somehow integrated. So that's the idea. So brutally speaking, we want to develop a low-cost computer vision interface, which provides useful information about daily life objects. We put it in this way. So what we want to do is to get a system who can recognize objects, but not only objects. We look also at gesture. And then, try to use this information in the future for to be applied to use this information on a robotic / prosthetic hand in order to pilot a robotic hand versus grasping the object, for example. But not only that, because as I said, we look at object recognition, but also at gesture recognition. So we can also think about having robots that mimic what I'm doing or use what I'm doing, recognize what I'm doing, and use this information for something else. For example, to vocalize a message that I'm giving with a sign language, or to, just imitate what I'm doing, or to interact, for example, at a cognitive level. So the ingredients are that we want to have a camera, we want to have a computer vision system, and then we want somehow in the future to combine this with a robotic hand and have some kind of self-grasping capability, for example. And we look, as we said, at gesture recognition and objects or objects recognition. So we put also this image because typically what we do in the lab is that, for example, we take a robotic hand and we interface this robotic hand with EMG, with so electromyography, and we activate and move the hand using the muscle contraction of, for example, the forearm. But here what we want to do is something a little bit different, and we want to rely on vision and not anymore on muscle contraction. Okay. So in terms of ingredients of this work, we selected a couple of cameras to capture data, and then to use this data in order to train and a convolutional neural network, and then use this training, this learning, to recognize what we have to recognize, to make a prediction. The selection of these two cameras is conditioned by the fact that we want something that is low cost, able to live stream high quality videos, but also we want to have streaming in the order of 720 pixel or 1080 pixel, and the capability to take static picture at high quality, because then we can use these pictures for our purpose. And the other thing is that you have to keep in mind this type of software that you want to use, and so you want to have something that is easy to set up and use. This is in terms of hardware, in terms of camera. In terms of software, we use two types of software. One is Anaconda Spider IDE, Integrated Development Environment, which is based on Python. The good thing of this platform environment is that you have also a set of libraries that you can integrate and install, and which allow you to add more functionalities, more features. And also we have the possibility to customize the package that we want to install. So you can tailor, the system according to what you want to do. And then together with Anaconda IDE, we also use a software which has very similar skills, capabilities, features, which is Jupyter IDE. But this Jupyter has also the possibility again to use Python as well, but it has also a browser interface. And again, you can benefit of libraries to add more functionalities, and you can also customize the packages that you want to install in order to again to tailor what you want to do. Then I mean we also look at OpenCV, which is is open. I mean everyone probably knows. You can perform real-time computer vision. It's an open source system. And also the good thing of this package is that you can manage the camera, so you can do the smoothing, define the region of interest, you can do the processing of the images. And we use TensorFlow, which is the famous machine learning platform, which allow us to interpret and process, in this case, the gesture recognition, the object or objects. And on top of TensorFlow, we also use Keras, which allow us to control the neural network, convolutional neural network. So the system is, when you set up the system, what you have is that you have a Spider ID controller, but also you have a Jupyter ID controller, which we call the AI interface. And then you have the camera. And what you do is, I mean, here we miss the part about how we train the system and so on. But the idea, maybe, if you're interested in more details, you can also contact us and we will send some details, because I think it can be interesting. But the idea is that you have basically a set of gestures that you can perform in front of the camera, or a set of objects that you present in front of the camera, And then you have what is called the camera capturing the human hand gesture or the object and objects, because we consider single object and scene where you have multiple objects which are present. And if everything works fine, you have an AI detection of the gesture recognition and or an AI detection of the object, single or multiple recognition. So this is the overall system. Again, this slide is not presenting the setup of the convolutional neural network that is behind. And I mean, if you want some details also about how we set it up and how we perform the, you know, the training of all the system, please drop us an email and we'll provide certainly further details. So what you have is if everything, when, you know, after you have performed the proper training of the system, we look at 5 gestures, which are palm, which is this kind of configuration where you look at only at the palm, you don't play with the fingers. Fist, which is when you close your hand. Peace, again, daily life gesture. L and OK. We put also L, which is a letter, because the reason of this setting this gesture recognition is also you can start to think about a system where you, for example, a robotic device on the other side can recognize what you're doing, daily life gesture, but also can, for example, recognize sign language. So you can provide some letters with your finger and then the robot recognize that. But you can also think about how to vocalize this letters and how to synthesize with maybe some voice, or so you can think about different applications. Again, we're proving the concept. So we did some trials. We did very preliminary trials, honestly. So we did 5 trials for each gesture after you set up the convolutional neural network and you train the convolutional neural network. And here we show the accuracy in terms of percentages. So what you have on average is results in the order, I would say, more than 80%. Some gestures are much easier to recognize, like, for example, fist, you had a success of 92%. And then you go a little bit down on with OK, which is again a very clear sign. So it should be easy to recognize, which is 86. And then you go to 84 with palm and 80 with peace and L, which are, you know, a little bit more difficult. Then we look at object recognition. So again, we set up a convolutional neural network. We did the training with some object, and we look how we can recognize symbol object. And again, the criterion was to use a daily life object. So we look at, you know, objects like a book, a phone, scissor, and then fruit like an apple, a banana, and so on. So what you do is that you do some, again, validation, preliminary validation. So 5 trials for each one. And again, you are in the order, or here you're losing something. For example, you have 70% and 72%, but then you go up to 75 and 82. So there are some objects that are a little bit more easy to recognize. But also, I mean, we look at single objects, but then we look also at how we recognize multiple objects together. So we put multiple objects in different combination, like, you know, a book, a phone, and a cup, phone and apple, a cup, and so on. Cup, banana, and book, apple, banana, and cup, banana, book, and phone. So, you know, you mix this object. And here is a little bit more difficult because you have to take, you know, to isolate the single object and then recognize. We did again 5 tests, and we present the percentage of recognition, and we are in the order again of more than 73%. Okay, so 73/80%, 78% with banana. So the purpose is again to prove the idea that we can have different scenario where, for example, you have a camera which is attached to your robotic and prosthetic hand, and just because you recognize the object, then you can tell to the robotic hand, the prosthetic hand, what to do versus the object. But you can think about different application which are, in any case related to human-robot interaction, I would say. So the conclusion is that at this stage we have some preliminary laboratory tests. We need clearly more proper validation with more field trials. However, the system, I think we prove that, the idea can work. Now, what is interesting is also to think about integration. So, for example, to integrate, as I said, this system into a robotic hand and do some tests. But the type of application we can think about can be different. For example, we had already looked a little bit on how to use this kind of technology, for example, for sign language recognition. So you can start to think about an interface where someone is talking to you through some sign language, and then you can translate this information into whatever you want. So you can write this information or you can vocalize this information. So I want to thank you, and I want to thank in particular my colleagues for their work. And if you are interested, please send us an email or contact us, and then we'll provide also the details about this work. Thank you.